Technology during World War I reflected a trend toward industrialism and the application of mass production methods to weapons and to the technology of warfare in general. This trend began 50 years prior to World War I during the U.S. Civil War, and continued through many smaller conflicts in which new weapons were tested. The earlier years of the First World War can be characterized as a clash of 20th-century technology with 19th-century warfare in the form of ineffective battles with huge numbers of casualties on both sides. It was not until the final year of the war that the major armies made effective steps in revolutionizing matters of command and control and tactics, to adapt to the modern battlefield, and started to harness the myriad new technologies to effective military purposes. Tactical reorganizations went hand in hand with armored cars, the first submachine guns, and automatic rifles that could be carried and used by one man. Trench warfare. The new metallurgical and chemical industries had created new firepower that briefly simplified defense before new approaches to attack evolved. Infantry rifles, rifled artillery and hydraulic recoil mechanisms, zigzag trenches and machine guns, and their application had the effect of making it difficult or nearly impossible to cross defended ground. The hand grenade, already in existence, though crude, developed rapidly as an aid to attacking trenches. Probably the most important was the introduction of high-explosive shells, which dramatically increased the lethality of artillery over the 19th-century equivalents. Trench warfare led to the development of the concrete pillbox, a hardened blockhouse that could be used to deliver machine gun fire. They could be placed across the battlefield with interlocking fields of fire. Because attacking an entrenched enemy was so difficult, tunneling underneath enemy lines became one of the major efforts during the war. Once enemy positions were undermined, huge amounts of explosives would be planted and detonated as part preparation for an overland charge. Sensitive listening devices that could detect the sounds of digging were a crucial method of defense against these underground incursions. The British proved especially adept at these tactics, thanks to the skill of their tunnel-digging sappers, and the sophistication of their listening devices. Artillery. At the beginning of the war, artillery was often sighted in the front line to fire over open sights at enemy infantry. During the war, the following improvements were made. The first box barrage in history was fired at Neuve-Chapelle in 1915. This was the use of a 3- or 4-sided curtain of shell fire to prevent the movement of enemy infantry. The wire-cutting No. 106 fuse was developed, specifically designed to explode on contact with barbed wire, or the ground before the shell buried itself in mud, and equally effective as an anti-personnel weapon. The first anti-aircraft guns were designed out of necessity. Indirect counter-battery fire was developed for the first time in history. Flash spotting and sound ranging were invented, for the location and eventual destruction of enemy batteries. The creeping barrage was perfected. Factors such as weather, air temperature, and barrel wear could for the first time be accurately measured and taken into account when firing indirectly. Forward observers were used to direct artillery positioned out of direct line of sight from the targets, and sophisticated communications and fire plans were developed. The majority of casualties inflicted during the war were the result of artillery fire. Poison gas. At the beginning of the war, Germany had the most advanced chemical industry in the world, accounting for more than 80% of the world's dye and chemical production. Although the use of poison gas had been banned by the Hague Conventions of 1899 and 1907, Germany turned to this industry for what it hoped would be a decisive weapon to break the deadlock of trench warfare. Chlorine gas was first used on the battlefield in April 1915 at the Second Battle of Ypres in Belgium. The unknown gas appeared to be a simple smoke screen, used to hide attacking soldiers, and Allied troops were ordered to the front trenches to repel the expected attack. The gas had a devastating effect, killing many defenders, or when the wind direction changed and blew the gas back, many attackers. Later, mustard gas, phosgene and other gases were used. Britain and France soon followed suit with their own gas weapons. The first defenses against gas were makeshift, mainly rags soaked in water or urine. Later, a relatively effective gas masks were developed, and these greatly reduced the effectiveness of gas as a weapon, although it sometimes resulted in brief tactical advantages and probably caused over 1 million casualties. Gas seemed to have had no significant effect on the course of the war. Command and control. In the early days of the war, generals tried to direct tactics from headquarters many miles from the front, with messages being carried back and forth by couriers on motorcycles. It was soon realized that more immediate methods of communication were needed. Radio sets of the period were too heavy to carry into battle, and phone lines laid were quickly broken. Runners, flashing lights, and mirrors were often used instead. Dogs were also used, though they were only used occasionally, as troops tended to adopt them as pets and men would volunteer to go as runners in the dog's place. There were also aircraft that could carry messages between headquarters and forward positions, sometimes dropping their messages without landing. The new long-range artillery developed just before the war now had to fire at positions it could not see. Typical tactics were to pound the enemy front lines and then stop to let infantry move forward, hoping that the enemy line was broken, though it rarely was. The lifting and then the creeping barrage were developed to keep artillery fire landing directly in front of the infantry as it advanced, communications being impossible. The danger was that the barrage would move too fast, losing the protection, or too slowly, holding up the advance. There were also countermeasures to these artillery tactics. By aiming a counter-barrage directly behind an enemy's creeping barrage, one could target the infantry that was following the creeping barrage. Microphones were used to triangulate the position of enemy guns and engage in counter-battery fire. Muzzle flashes of guns could also be spotted and used to target enemy artillery. Railways. Railways dominated in this war as in no other. Through railways, men and material could be moved to the front at an unprecedented rate, but they were very vulnerable at the front itself. Thus, advancing armies could only move forward at the pace that they could build or rebuild a railway, e.g., the British advance across Sinai. Motorized transport was only extensively used in the last 2 years of World War I. After the railhead, troops moved on foot and guns were drawn by horses. The German strategy was known beforehand by the Allies simply because of the vast marshalling yards on the Belgian border that had no other purpose than to deliver the mobilized German army to its start point. The German mobilization plan was little more than a vast detailed railway timetable. Railways lacked the flexibility of motor transport, and this lack of flexibility percolated through into the conduct of the war. War of attrition. All countries involved in the war applied the full force of industrial mass production to the manufacture of weapons and ammunition, especially artillery shells. Women on the home front played a crucial role in this by working in munitions factories. This complete mobilization of a nation's resources, or total war, meant that not only the armies, but also the economies of the warring nations were in competition. For a time, in 1914–1915, some hoped that the war could be won through an attrition of materiel, that the enemy's supply of artillery shells could be exhausted in futile exchanges. But production was ramped up on both sides and hopes proved futile. In Britain, the shell crisis of 1915 brought down the British government, and led to the building of HM Factory, Gretna, a huge munitions factory on the English-Scottish border. The war of attrition then focused on another resource: human lives. In the Battle of Verdun in particular, German Chief of Staff Erich von Falkenhayn hoped to bleed France white through repeated attacks on this French city. In the end, the war ended through a combination of attrition, advances on the battlefield, and a breakdown of morale and productivity on the German home front due to an effective naval blockade of her seaports. Air warfare. As with most other technologies, the aircraft underwent many improvements during World War I. While early air spotters were unarmed, they soon began firing at each other with handheld weapons. An arms race commenced, quickly leading to increasingly agile planes equipped with machine guns. A key innovation was the interrupter gear, a German invention that allowed a machine gun to be mounted behind the propeller so the pilot could fire directly ahead, along the plane's flight path. As the stalemate developed on the ground, with both sides unable to advance even a few miles without a major battle and thousands of casualties, planes became greatly valued for their role gathering intelligence on enemy positions and bombing the enemy's supplies behind the trench lines. Large planes with a pilot and an observer were used to reconnoiter enemy positions and bomb their supply bases. Because they were large and slow, these planes made easy targets for enemy fighter planes. As a result, both sides used fighter aircraft to both attack the enemy's observer planes and protect their own. Germany led the world in the design of Zeppelins, and used these airships to make occasional bombing raids on military targets, London and other British cities, without any great effect. Later in the war, Germany began attacking English cities with long-range strategic bombers. As with the Zeppelin attacks, Germany's strategic bombing of England had limited tactical value, but it was demoralizing and showed the British they could not be completely immune from the effects of the war in their own country. It also forced the British Air Forces to maintain squadrons of fighters in England to defend against air attack, depriving the British Expeditionary Force of planes, equipment, and personnel badly needed on the Western Front. Manned observation balloons floating high above the trenches were used as stationary reconnaissance points on the front lines, reporting enemy troop positions and directing artillery fire. Balloons commonly had a crew of 2, each equipped with parachutes. Upon an enemy air attack on the flammable balloon, the crew would jump to safety. At the time, parachutes were too heavy to be used by pilots in aircraft, and smaller versions would not be developed until the end of the war. Recognized for their value as observer platforms, observation balloons were important targets of enemy aircraft. To defend against air attack, they were heavily protected by large concentrations of anti-aircraft guns and patrolled by friendly aircraft. By inhibiting the enemy's ability to move in secrecy, aerial reconnaissance over the front can be blamed to some degree for the stalemate of trench warfare. Tanks. Although the concept of the tank had been suggested as early as the 1890s, few authorities showed interest in them until the trench stalemate of World War I caused serious contemplation of unending war and ever-escalating casualties. In Britain, a Land Ships Committee was formed, and teamed with the Inventions Committee, set out to develop a practical weapon, based on the Caterpillar track and the 4-stroke gasoline-powered internal combustion engine. Early World War I tanks were fitted with Maxim-type guns or Lewis guns, armor plating, and the Caterpillar tracks were configured to allow crossing of an 8-foot-wide trench. Early tanks were unreliable, breaking down often. Though they first terrified the Germans, their use in 1917 engagements provided more opportunities for development than actual battle successes. It was also realized that new tactics had to be developed to make best use of this weapon. In particular, planners learned that tanks needed infantry support and mass formations to be effective. Once tanks could be fielded in the hundreds, such as at the Battle of Cambrai in November 1917, they began to show their potential. Still, reliability was the Achilles heel of tanks throughout the remainder of the war. In the Battle of Amiens, a major Entente counter-offensive near the end of the war, British forces went to field with 534 tanks. After several days, only a few were still in commission, those that suffered mechanical difficulties outnumbering those disabled by enemy fire. Regardless of their effects on World War I, tank technology and mechanized warfare had been launched and grew increasingly sophisticated in the years following the war. By World War II, the tank had evolved to a fearsome weapon which made the trench obsolete, just as the trench and the machine gun had made horse-mounted cavalry obsolete. Naval warfare. The years leading up to the war saw the use of improved metallurgical and mechanical techniques to produce larger ships with larger guns and, in reaction, more armor. The launching of HMS Dreadnought revolutionized battleship construction, leaving many ships obsolete before they were completed. Consequently, at the start of the war, many navies comprised newer ships and obsolete older ones. The advantage was in long-range gunnery, and naval battles took place at far greater distances than before. The Battle of Jutland was the only full-scale battle between fleets in the war. Having the largest surface fleet, the United Kingdom sought to press its advantage. British ships blockaded German ports, hunted down German and Austro-Hungarian ships wherever they might be on the high seas, and supported actions against German colonies. The German surface fleet was largely kept in the North Sea. This situation pushed Germany, in particular, to direct its resources to a new form of naval power: submarines. Submarines. World War I was the first conflict in which submarines were a serious weapon of war. In the years shortly before the war, the relatively sophisticated propulsion system of diesel power while surfaced and battery power while submerged was introduced. The United Kingdom relied heavily on imports to feed its population and supply its war industry, and the German Navy hoped to blockade and starve Britain using U-boats to attack merchant ships in unrestricted submarine warfare. This struggle between German submarines and British countermeasures became known as the First Battle of the Atlantic. As German submarines became more numerous and effective, the British sought ways to protect their merchant ships. Q-ships, attack vessels disguised as civilian ships, were one early strategy. Consolidating merchant ships into convoys protected by one or more armed navy vessels was adopted later in the war. There was initially a great deal of debate about this approach, out of fear that it would just provide German U-boats with a wealth of convenient targets. Thanks to the development of active and passive sonar devices, coupled with increasingly deadly anti-submarine weapons, the convoy system reduced British losses to U-boats to a small fraction of their former level. Lieutenant Otto Weddigen remarked of the second submarine attack of the Great War: mobility. Between late 1914 and early 1918, the Western Front hardly moved. Ironically, the beginning of the end for Germany started with a huge German advance. In 1917, when Russia surrendered after the October Revolution, Germany was able to move many troops to the Western Front. Using new stormtrooper tactics developed by Oskar von Hartier, the Germans pushed forward some tens of kilometers from March to July 1918. These offensives showed that machine guns, barbed wire and trenches were not the only obstacle to mobile warfare. In the Battle of Amiens of August 1918, the Triple Entente forces began a counterattack that would be called the 100 Days Offensive. The Australian and Canadian divisions that spearheaded the attack managed to advance 13 kilometers on the first day alone. These battles marked the end of trench warfare on the Western Front and a return to mobile warfare. The sort of unit that now began to emerge combined cyclist infantry and machine guns mounted on motorcycle sidecars. These motor machine gun units had originated in 1915. The Hindenburg Line fell to the Allies and the Canal du Nord was crossed. In Berlin, Kaiser Wilhelm was told Germany had lost, and must now surrender. Advances continued, but political developments inside Germany compelled Germany to sign an armistice on November 11, 1918. The war was over, But a new mobility-driven form of warfare was beginning to emerge, one that would be mastered by the defeated Germans and deployed in 1939 as their Blitzkrieg, or lightning warfare, embodying all they had learned in 1918.